Hello everyone, welcome once again to another data analytics tutorial by Team SlideScope. In this part we are creating a simple Power BI dashboard on transformer dataset. So we have input voltage current etc. and efficiency percentage of these transformers, and we are trying to analyze how different features are affecting efficiency. Features like what type of cooling method is used, what is average efficiency by core material, average efficiency by load type, winding material, and then winding material, load current and efficiency, where you can see for different type of winding material how efficiency and load current are related. So this and average efficiency by cooling method and winding material, everything that you see here, we will try to create this type of dashboard where we have different type of filters that we can apply like this, or if we'll suppose click on this, we will be able to filter the data accordingly. So everything that you see here will be discussed in this part. Let's get started. Understand this part 1. This series or this particular project will have multiple parts. So we will open Power BI desktop, and in Power BI desktop we will load this dataset which is given as a CSV file. I will provide the link of this dataset to you. Here you can see we have get data option. We will click text CSV, and here you can see a lot of data sets are stored. So this is transformer efficiency dataset file which we will connect here, and make sure all the columns and their values are properly uh, you know attached with each other, like we are not seeing any incorrect column names. Then we can simply load it. Otherwise we have to transform data and use first row as header, which we have done in many examples. Now here you can see, so I will just rename this as TF efficiency, which is short for transformer, and I will simply go to insert and add a text box, and here we will write transformer efficiency analysis dashboard. And we are basically trying to analyze factors affecting efficiency of a transformer. We will align center and use 24 font size like this, and here we will again go to the same URL where I will just add something like features influencing performance or features influencing transformer efficiency. So I will just write features affecting transformer performance. So you can use this. Now for this we can use another font size like 14 pixel, and we can use some color. Currently I am using this color for main heading, and maybe this color for subheading, and this is how I will create my heading. And if we have more space, so I can also use probably 28 font size, and for this let's use 18 font size. So we have this, and mostly what I do is I select this text box, go to effect, enable shadow here, and if needed visual border, which I'm not going to enable right now, and I will just give a look and feel like this so that we have some 3D kind of look and feel to it. Now we can save it. So we will be saving it in another location. So I am saving it in this location as TF efficiency project. So idea is to analyze features affecting efficiency here, and then create machine learning model using Python. So here itself we will be using Python visuals, where we will enable script visuals and do that. So this will be a multi-part project. where you will learn all of this. So transformer efficiency analysis, and we will add a simple shape for our filters, because a lot of these categorical values that are given to us, these categorical values are will work as filters for us. And here we will select some color. Let's go with this color as a filter background color. And here we can add some image. Let's say we are doing analysis for some company which manufactures these transformers. So we can put that, or we can add image or icon of a simple transformer, which we will do that. But before that, we need to understand the data set. What is meaning of this data set? What are these features? So let's see. So the data set that we have with us is transformer efficiency data set, where we have transformer ID, input voltage, load current, core loss, copper loss, etc. And we have some categorical columns like core material, cooling method used in that transformer, and its efficiency. Most of the efficiencies are in a very close range. And if you will see this particular article here on OD Tutor, so here we have example that when analyzing the efficiency of an electrical transformer, so both type of features can influence performance, and here you have lot of features. So when we generated this data set, we use some of these features, and here is the efficiency formula, that it is equal to output power divided by input power, where these technical values are written: V2I2 cos phi, V2I2 cos phi plus P core plus PCU, which is iron loss and copper loss. So when this value is given, so we have copper loss value is given to us, and core loss or iron loss value is also given to us, and input voltage and load current is also given. So on the basis of these values that we have, we will connect this data with our favorite BI tool, and then create a simple data analysis dashboard, so that we can analyze which factors are affecting the efficiency more, and so that we can create a machine learning model that can predict the efficiency of a transformer if all these values are given to us. Now we will insert that image which I have created using Canva, created or simply downloaded it in a transformer. It's a transformers image or icon, and it has a transparent background. So that's what we can do. Now, since you have understood little bit about the data set, so what we are going to do is first we will create some KPIs. So for KPIs, we create simple card visuals. These card visuals can show a single value. So we are going to show single numbers, and these numbers will define what or how our data is given to us. So first thing is we will add how many different transformers we have. So we will drag transformer ID here. So you can see when you will drag a string value or a text value, so it will show its first value. Instead, you can use count distinct. So now you will see how many distinct transformer IDs you have. And we can simply rename for this visual as count of transformers. And here again, we are going to use the same combination. So for call out value, let's use this font color. And this is category label, that's something that you are seeing below it. And for category label, I will use this. We can disable category label also, but if you will keep it, so this thing will be dynamic. One thing that I'm going to do is go to general tab, properties, padding, and reduce top padding, so that I can fit, I can align them more towards center, and I can try to increase padding from bottom, but without clipping the text. So now this is okay. Here we are going to select effects, general properties, effects, shadow, and if you want you can give rounded corners also, that I have done in many previous tutorials. So this is count of transformers. We can go to home tab. Let me, yeah, zoom it for you. So we can go to home tab, copy, paste. It will create a copy of it. Paste one more time. I will paste 3 or 4 times and one more time. So this is what I'm going to do, and then we can reduce their width to fit all of them. Second will be copper loss. So for all transformers, sum of copper loss is this. We will select average copper loss. So this is what which we have, and we can rename this as average, and this is in watts. So, and basically 1.23 kilowatt, you can say average copper loss. If these headings are not properly visible, so we can go to category label and make them bold as well. So we can copy format, apply here as well. So we can just increase with a little bit. So this is average copper loss. And let's see iron loss or core loss. So same thing we'll do. We'll add core loss and see what is average of core loss. Let's copy the same formatting and apply here, which is given like this. So basically in a transformer, at there are primary and secondary windings. So whatever power you supply in primary end should be there in the secondary end, but some energy is lost, and because of that there is the, that's why the efficiency is not 100%, and because of these losses, different type of losses we have. So we are trying to analyze how these losses affect efficiency and what type of transformers, like if load type is a particular type or a core material is something, like when winding is done in a transformer, so sometimes aluminum is used or copper is used mostly, but sometimes aluminum is also used. So do we have any difference there? So that's what we are trying to analyze and visualize here, so that we can understand more about this. So this type, if you are just a IT person, like you don't know anything about how transformers work, I will ask you to, I suggest you to learn basics of transformer. Although I think transformers is something that we have all read in physics in our high school or before that as well. But if you will understand, you will be able to understand this particular data set, this particular analysis in a better way. Now again we have this, so we can write input voltage. So let's say what is input voltage and what is average of input voltage, and here we will select that, rename that average input voltage, this, and finally we can select something like, which is our target field efficiency. So we can select, obviously not sum of efficiency, but what is average efficiency of a transformer, which is 97.19%. So yes, and you can add more values also. So instead of count of transformers, I will simply put, we have done input voltage, we can also do load current. So this, and instead of sum we'll select average load current. So this is how the important parameters are there, and you already saw in that article that there are many such features or many such properties that can affect the efficiency, and you can see frequency, rated power, core loss, copper loss, temperature rise, ambient temperature, winding resistance, oil level. Like there are some transformers which are oil cooled transformers, so it affects cooling and indirectly affecting efficiency. So I have given this article here so you can read it in a more detailed way. So now we have created some KPIs. Now next step is I add some filters and check those filters that these numbers should change. So for example, we have different categorical fields. We put all numerical fields as KPIs and categorical fields can be used as filters. Like in core material there are either amorphous steel or CRGO steel. A CRGO steel is a cold rolled grain oriented electrical steel and is a specialized type of silicon steel used to make core of transformers. Like factory workers will stack them together and then create core. If transformer is of it's used in transformer which are large in size mostly, but this is how they prepare core. So you can watch some videos also that will help you how core of a transformer is prepared in a factory. And then there are amorphous steels also, so we are going to use them. So we can see, obviously see, efficiency will not change too much because it is between 96 to 99% range in all the transformers that we have, but we can see slight variations. So for that we are going to use a slicer here, and here we will add a slicer, and then in this slicer I will drag cooling method. It will automatically show me all type of cooling methods, whether dry type, ONF or ONN. These two cooling methods are there. ONN, oil natural, air forced, oil natural, air natural. Like these are different type of cooling. So here I'm going to just use it as a drop down list, and I will go to general tab, effects, remove this background, and I will select this, and in slicer header let's use another font color like this. You can increase its size, but now values are there. So either you can keep the values like this, but if you want to see values properly, so you will also change value color to light color. But problem is now we have a light background. Then we fix this problem by going to background and selecting the same color. So now it appears like a transparent filter to us. That's what we can do. So this is cooling method. Now we can copy and paste. So copy and paste, or control C, control V. Now after cooling method, another categorical field is core material. Then copy and paste, and after core material we also have load type. What type of load is there? So in load type we have values like commercial load, industrial load, or residential load. So these transformers are sometimes installed in a factory where commercial loads are there, heavy loads are there. Commercial can be something like a bank or an IT office. Industrial is obviously, as I mentioned, a factory or industry. Residential is like in suppose there are 10 apartments. So to avoid voltage loss or voltage drop, they will install a small transformer nearby so that there is voltage quality is good, around 220 volts in most of the cases. So load type, and here we will have another filter like this where we will use winding material, and as I said in our example, winding material are either aluminum or copper. So we can use it like this. So we can arrange these filters like this, and if you have more space you can keep some of them open as well. For example, instead of drop down I can show a vertical list. So for this at least, so this is also something that can be done. So because we don't have many values here, so we can show them as vertical list also. So let me do that. We are going with open list here. Now thing is, if I want to analyze, and one more thing I can do is I can go to effects and enable a visual border and select a light color like this, and then I can copy the formatting and apply in all. So formatting all. So now every one of them have borders, so we can arrange them. As I am doing styling, you can see these values are changing. So in case of aluminium, you can see average load current, average copper loss. In case of copper, you can see this. Then amorphous is steel, CRGO steel, industrial load it is. So you can see that all these values are changing. That in on-n it is 1.24K, and on-f, sorry, in on-n it is 1.22K. So some difference there. So this is what you can see in these examples. As I said, this is fabricated data that I prepared based on whatever basic knowledge I have. If some expert is watching this, you can always correct us. You can give us some data if you already have for educational research purpose, and other students will also be benefited with it. And if you need to share your expertise, you can share with us. In an actual case, I'm sure this will differ, but this is how you will prepare a dashboard and get insights from it. Like for what kind of core material is the copper loss or winding loss increasing, or core loss or iron loss increasing in what type of core material, in what type of winding material, winding loss is increasing. Efficiency is higher, like 97.33 in copper, 96.88 in aluminum, so it is lower. So that's what you can check. Now here, when we are applying this, so we are seeing that yes, values are changing, but to see them in actual case, we'll consider efficiency as our target field and then create simple visuals to do that. Now let's say we want to see cooling method wise efficiency, average efficiency. So we will select a stack bar chart here. Sorry, we will, let's press Ctrl Z. We'll click here somewhere and add a stack bar chart, because in a stack bar chart we can see one categorical data and one numerical data. We can compare them. So we will select cooling method here on y-axis, and on x-axis we will select efficiency. So what I'm going to do is I will create a new measure and using simple DAX formula average. So this is average efficiency. Please check spellings at your end also. I may make some mistake. It is average efficiency, where average, and we will use efficiency percentage. Now, so this is efficiency, and if we add it here, so you can see obviously these values are very close to each other. That's why we are not seeing too much difference here, but at least we can enable data labels to show those values, and you can see it is showing as 97. It is basically um, summarizing or rounding it. But if we go to value, where average efficiency is given, display unit is given, if we say none, so then you can see it is showing us value, and decimal places I will say 2. Now we have some difference in value. Here one thing can be done is, first thing, we can copy it, format painter and apply, so that same border is there. Now you can see data label font color is changed. So we will go to value and we'll change the color back to this or bright color. And then in general we have title. So for title I'm going to use this color which I have used here. So now this is average efficiency and I will just align it to center and I can increase its size. This is average efficiency by pooling method. And here we have more settings, like obviously in this case there is no need to enable legend. We can enable or disable zoom slider to filter values. Bar color for all values is the same, but if you want you can select for different. For example, for ONAN, if you want you can select this color. I'm just giving you an example. For ONAN we can select this color, and for try type you can select this color. So you can also change colors for them, so which is optional. Now because these numbers are very close to each other, so by just visualizing it you will not be able to clearly see which one is bigger, which one is smaller, although we know that by these labels. But here in such cases, if you go to x-axis, you have range of minimum to maximum. So if I start the range with 95, okay, so you will be able to see that now we can see the difference. Even I can start with 96 because that's what the minimum value starts with. On 97 this value will go, so I will start with 96 here, and we are not able to see the third value. So we will again select this, and its position is auto. I will select inside end. So this is also how you can, even though the numbers are close to each other, but to clearly see which one is winner, you can do that. One more thing, in y-axis these values are given, so obviously it's okay that we have selected. Let me select a dark color at least, and we can make it bold, so you will be able to see these values also. So this is how you can compare them. And now I will copy it and paste it here. So this is average efficiency by pooling method. Then we also have to see by core material. So for core material I am going to use a donut chart, and so first I'll use donut chart and select core material. So here also you can see we have these values. Now uh, when we have a donut chart or a pie chart, here you can see those settings are not there. Here we have different kind of settings. So this is legend. You can see its position, that center left, okay, or where do you want to keep it. Its text is given, what size you want. So this information is given here. In your slices you can select different colors. For Amorphous steel I'm going to select this color, or maybe slightly lighter color. For CRGO I'm going to select this color, although you can change as per your requirement, and it is changing that dynamically. In details you can see position is outside, so we can say prefer outside. But in values, because these values are actually visible, but because we change the color, so it's not visible, so we'll change color like this. And now you can see the efficiency. So that's how you can change it, like what is value decimal places, percentage decimal places. And we will only see values, data values. So we will just select this. It is 97.10, 97.54. That's what these values are. So this is average efficiency by core material, and we can create another visual here. So we want three visuals of equal size. So we can reduce with a little bit here, and try to arrange it and reduce with little bit here as well and adjust them. Later I'm going to make them all of equal size, which you can do by clicking here, going to visual setting, general setting, property. You can see width is 337, so let me keep it 335 for all of them. 335, 335. If these visuals are of equal width and aligned properly, then they look great actually. So that's why the symmetry is there. So I will just do that. So now we have these two visuals. Third important parameter for us is what kind of load is there. So on the basis of load type, we can select this. So for commercial load, what is efficiency for residential and industrial? And I'm just going to use a vertical column. Here again, these values are there. So I will change, or I will simply copy format painter and apply it here. So it will automatically change. Now here in this case, this value comes to y-axis. So let's keep minimum as 96 there. So now we have data like this, right? So that's how we can compare. For commercial loads, efficiency of these transformers is higher as compared to industrial loads as per the data that we have. So this is what you can get from this data. Next, we have winding material. In winding material, we have either aluminum or copper. So wherever we have two values, we can select pie chart, bar chart. These kind of charts can be used. So I'm going with a pie chart. I will simply copy this and paste it here. Instead of core material, I will just select winding material, and you can see for copper and aluminum we have this value. I'm just going to change these colors little bit. So for this I'm going to use this. For copper, let's select some color that is like copper, and for aluminum we can actually select a silver color so that it represents. So here also you can see in case of copper it is higher, and if you will click on any one of them, you will be able to see the efficiency like this as well. So this is also something you can do. Now what we have done is we have seen one versus one chart, but what if someone asks you, we have to see a combined effect of cooling method and winding material on efficiency. So for such questions we can use a ribbon chart also. Let me show you how. So we will first copy this because I don't want to reapply styling, and click it and use ribbon chart. Now in ribbon chart, on x-axis I will put cooling method so that we will have 3 bars, and as a y-axis I will select average efficiency, that is our target field. So you can see how it is there. But in legend, because legend represents color, as you can see, so categorization, in legend I will select winding material. You can also select core material. So now you can see this is showing us average efficiency by cooling method and winding material, and it is clearly showing us it doesn't matter what kind of transformer it is. In every case, copper has a better efficiency than aluminum in all type of when all type of cooling methods are there for all transformers. So that's what this does. Instead of winding material, if we use core material, then also we will see the same thing. If we select load type, then also we can see that in commercial load efficiency is higher. So that's how actually we can answer this question. Let me just add winding material here, and here we have legend information. So you can see legend position is center left. We will select top left so that at least we have this information. This is average efficiency by cooling method and winding material. So which we can see here. Here also we have axis, but in this case you can see we have more features like what font, you can concatenate labels, you can enable disable title, layout, minimum category width you can increase or decrease here. So on the basis of that you will show values. This is your y-axis. In this case it is showing range. I am just going to select 96 here. Just a minute, let me select properly. So I will start with 0. So other than that there is no need to change, so I will just keep it like this. And suppose you want to see something like what is effect of input voltage or what is effect of load current on this. So you have to create a scatter plot mostly, because scatter plot or a line plot. So I'm using a scatter plot because we have many examples. So let's say if I put input voltage on x-axis, and on y-axis if I put efficiency percentage, and I say don't summarize, and for this also I say don't summarize. So that's how you can see how input voltage versus efficiency percentage is given. And if I also drag current here, so you can see the field values in your y axis are mismatched because they have different, they have different units. One is in ampere, one is in volt, and their scales are also different. So we can create two separate graphs, and we can copy formatting here also. So this is showing input voltage versus efficiency, how it is changing. And if we try to increase a trend line, this is how you can select. You can, although you can analyze with respect to current. So for example this, so this is how it is changing with respect to current. Instead of sum you can say don't summarize. So this is what it is doing. And here also if you add trend line, it has a slightly upward trend. In actual case these values will have a different shape. If we go with a line chart, you can see we will not be able to create it. That's why we use a scatter plot here. And in between, as a legend, let's say you want to add load type, so you can add different kind of load type and see where they fall. Or if you want to see cooling method, you can see where they fall. Or for different winding materials, so you can see. And when we are using legend, so we can again change their position to top left. This is winding material, load current, and efficiency, which you can see. So this is something you can analyze. And as I said, this is just an introductory chapter, chapter 1. So I'm just going to put part 1 here so that you can understand there are many other chapters going to be there in this part, in this series, because here we have to understand that based on a real world scenario, how transformers work, how their efficiency works, how different features affect its efficiency. As a data analyst, we are trying to understand all of that from the data that we have, which is very important for us. So everything that you see here, more questions, more visuals, and here we tried to create everything without using DAX or without using too many DAX functions, but obviously we are going to use them. So that is what is going to be in the next part. So please watch this series so that you can understand those type of questions as well. So if you have any questions, if you want to suggest something, please put your suggestions and questions in the comment section so that we can go through them and answer you accordingly. And please subscribe to our channel, because we are coming with more real world examples for you guys so that you can create these kind of dashboards and put them in your resume or your profile. Thanks for watching this. Have a nice day. See you in the next part.